This lesson will demonstrate a mathematical approach to identifying outliers and also look at the effect that outliers have on statistics such as the mean and the median for a data set. So here's our definition of an outlier. It's a value which is more than 1.5 interquartile ranges beyond the upper or lower quartile. So to calculate, we need to identify the lower quartile and the upper quartile. We need to calculate 1.5 times the interquartile range, subtract it from the lower quartile, and add it to the upper quartile. Anything which is below the first value or above the second value is classified as an outlier. In this example, we have 30 students, each recording the number of hours they watched a television programme in a month, and here are the results. I'm going to start by constructing a dot plot for the data so that I can visualise it more clearly. A quick scan over the data. Looks like 21 is the highest value. So my horizontal scale is the number of hours watched, and each student is represented by a dot on the diagram. So the first student watched 8 hours, then 10, then another 10, and so on. To work out the mean of the data, I could go back to the original scores, add them all up and divide by 30. But that would be quite tedious. One of the benefits of putting the data in a dot plot is we now have a frequency diagram, and so I can calculate the mean more quickly. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores of 8, 3 scores of 9, 6 scores of 10, 6 scores of 11, 2 12s, 2 14s, and a 21. This is quicker than adding up each of the individual scores. I can now add up these 2-digit numbers, giving a total of 306, and this I need to divide by 30, which is 10 and 6/30ths, 10 and a fifth, or 10.2. And that's my mean. To work out the median, I need to put the data in order and find the middle score. And another benefit of a dot plot is that we now have the data in order. We have 30 scores, so our middle score is between the 15th and 16th scores. We have 10 8s, 11, 12, 13, 14, 15. 15 and 16 both have a value of 10, so our median is 10. Now this score of 21 looks like it might be an outlier. It may be that this was mistyped, it may be that the student misunderstood the question, but it seems unusually high compared to the rest of the data. We're not going to discount it, we need to check mathematically if it really is an outlier. Firstly, we need to work out the interquartile range. For that we need the upper quartile and we subtract the lower quartile. Now the upper quartile is the median of the upper half of the data. So we take those 15 scores which are above the median, so our median is between these two scores here, and of those 15 scores it's going to be the 8th value. So I can count from the 10 or from the 21. Our upper quartile is 11. And the lower quartile is the median of the lower half of the data. So we take the 15 scores below the median and it's going to be the 8th value, which is 8. So that gives us an interquartile range of 3. Now remember that we need to multiply that interquartile range by 1.5, and 1.5 times 3 is 4.5. Then we add this to the upper quartile. So our upper quartile was 11, and 11 plus 4.5 is 15.5, and we subtract that 4.5 from the lower quartile, which was 8, so that's 3.5. Now we have an interval, and anything outside of this interval is classified as an outlier. So that 21 is an outlier, and we would need to say 21 is an outlier because 21 is greater than 15.5. To summarise what we've done so far, we found the mean by adding up the scores multiplied by their frequencies and dividing by the sum of the frequencies, which was 306 divided by 30, 10.2. The median was between the 15th and 16th values, and both of those scores were 10, so the median is 10. We identified the outlier of 21, and we justified that because we worked out that 21 was greater than 15.5, and the 15.5 was calculated by multiplying the interquartile range by 1.5 and adding it to the upper quartile. So what effect does that outlier have on the mean? Let's assume now that it is an outlier. It's some sort of mistake, a mistype, maybe a misunderstanding. Because the mean depends on adding up all of the scores and dividing by the number of scores, the outlier will have raised the mean. And we can justify that by calculating what the mean would have been without that outlier. If we take off the 21 from the score of 306, that's 285, and because we're not including score of 21, we've only got 29 scores now, so our mean without the outlier is 285 divided by 29. And even without calculating this, we can see that it's going to be less than 10. But what about the median? Let's think about what the median would be without that outlier. If we've only got 29 scores, the median would be the 15th score. But remember, the 15th and the 16th scores were both 10. So the median without the outlier would still be 10. So what we can see here is that the outlier in the data has a greater effect on the mean than it does on the median. Often we would use the mean to represent a typical value for the data. But if there's possibly an outlier in the data, we might consider that the median could be a more reliable score to use. We don't necessarily discount the outlier unless we're instructed to do so, because it may well be that there was a student who watched 21 hours of that programme in the month, but we just need to consider whether it's going to be reliable to use that value.